singing feelings, somebody throw something at me. So I start off by asking folks to feel free to interrupt me, ask questions. I think the best time to ask questions are when they pop into your mind. And actually, it's a fun little game I play. I try and see how quickly I can answer your questions in future slides. So I want you to ask questions when they pop into your mind, because if I say we're going to cover that in the next slide, it tells me that I've got things in a logical order, that I'm thinking like you're thinking. So please feel free to interrupt. And Brandon, I've told him that if we run too long because you're asking too many questions, that's a great thing, and he'll eventually pull me off the stage or take the microphone if we go too long. So it's great to be here. This week is spring break week at Iowa State University, and so people looked at me a little strangely when I said I was going to Fargo for spring break. It's not usually where we head in Iowa to take a spring break trip, but actually it's better than the past 3 years. I think I've been up here in February, so we're moving in the right direction. I'm now into March, mid-March, and eventually I may make it up here during the growing season, so I hope so. This is great weather though. So I want to start off every talk I give almost, I start off with biology. And the reason for that isn't to turn you into a biology nerd like I am, but it's because everything else we do to manage soybean cyst nematode is based on the nematode's biology. So nematodes are worms that live in the soil. You might find it interesting to know that not all nematodes are bad. Most nematodes don't feed on plants. They break down organic matter, they cycle nutrients. So if we could come up with a magical chemical to spread on the field that would kill all nematodes, we would do more harm than good. We wouldn't want to use it. But we do want to control the nematodes that feed on plants, and soybean cyst nematode is among the worst of those types of nematodes in the whole world. It's very difficult to manage and control because of its biology. So like all nematodes, soybean cyst starts out as these little eggs. They look like colorless jelly beans. And what hatches out of the egg is a worm that we call a juvenile. And that juvenile is a weak link in the life cycle. If that little squiggly purple thing you see on the screen, that juvenile, doesn't get into a soybean root and start to feed, it's going to either starve or something is going to eat it for lunch. Because in the soil, everybody's eating everybody else for lunch. And there are many organisms that feed on nematodes as a food source. So the nematode's vulnerable after it hatches until it gets into a soybean root. But unfortunately, for us soybean growers, more often than not, it's going to find a good host, and it's going to get into that root and start feeding. Now in this picture, the little purple blob there is the nematode. So it's gone from a thin worm to kind of a thing that looks like a piece of breakfast sausage. In fact, we call that a sausage stage juvenile. And at this point, I can't tell you if that's male or female. They look exactly the same. But if that's going to become a male, that's as big as it gets. And after it's swollen to that shape, it actually changes back into a worm, and it leaves the root, and it goes back out into the soil. So it's a little confusing. Males and females look identical in eggs and in juveniles and in swollen juveniles, but at this point, this will change back into this worm and go back out in the soil. And so this is about 4 times as large in nature as a juvenile, but it's just like a big version of the juvenile. Now, if this is going to become a female, this swollen juvenile is going to continue to get bigger and bigger, and eventually it takes on this football shape. So identical shape for part of its life, and then eventually adult females and adult males look very different. Now these adult females get so big that they pop out of the root, and you can see them on the surface of the root. Has anybody seen them? They're little white dots. So I see some people raising their hand, and they're wearing glasses like me, so you don't need eagle-eye vision to see them. They're about the size of a period at the end of a printed sentence. And they're little white dots. Now at this point, they're on the surface of the root, and the males, remember, they're back out in the soil, and they're blind, they don't have eyes, but they're attracted to the females by a chemical signal given off by the female. And rumor has it, if it attracts males, it must smell like beer. We haven't been able to confirm that, but there is a really strong chemical signal given off. Males get attracted to females, and then the males mate with the females. So this is an adult female. She has a little clump of eggs outside of her body on her rear end, and she produces about 50 eggs there. But then she fills up internally with another 200 to 250 eggs inside of her body. And eventually that kills her, because there's no room for her organs to function once she fills up with eggs. And once she dies, she changes from this white color to a brown color, and that body forms a nice hard shell. And that's what we call a cyst. So the name of the critter here is soybean cyst nematode. A cyst is nothing more than a dead female full of a couple hundred eggs. And then the life cycle continues. Some final points about this. Once we get to the middle of summer, it's cranking through a generation every 3.5 weeks. It takes 5 or 6 weeks for the first generation to happen because it's a cold-blooded animal and spring soils are cold. So it takes it a little while to get its first turn of the life cycle. Second turn of the life cycle, probably a little bit quicker. And then by that time, you're in the middle of summer and it's cranking through every 3.5 weeks. So up here, you might get 3 or 4 generations in a season. I've seen years where we think we've got up to 6 generations down in Iowa. With each female producing a couple hundred eggs, numbers can build up very quickly. Another point here that's really important is these females are mated by more than one male. And the reason that's important is the offspring, the eggs produced by the female, are all mixed up genetically. And that gives it a great ability to adapt to different conditions, because not all of the offspring have the same parents, the same father and mother. And then finally, if all that weren't bad enough, the eggs inside of the cyst can live 10 years or more without food. So the fact of the matter is, once you have a field infested with soybean cyst nematode, you're probably not going to get rid of it unless you just stop growing soybeans for the rest of your farming career. But it's not a death sentence. What my job is to help you, and other university faculty's job is to help you continue to grow soybeans profitably. And we can do that. But understand that once you've got it, you're probably never going to get rid of it. So any questions about that? I'm tired already. That was a lot to go through in one slide. It gets easier after this. Okay, realities of growing soybeans with SCN in North Dakota. There are 2 kinds of soybean farmers here in North Dakota. Those that are concerned about SCN and those who should be. And the reason for that is this. So this is a map of the soybean producing counties in the United States from 2008 to 2013. And now I've colored in red the counties where we found soybean cyst nematode. So where's the growth potential for soybean cyst nematode? You're in prime growth potential. I don't know what's going on over here in Pennsylvania other than my reputation might be keeping soybean cyst nematode out of my home state. I really don't know. Actually, I grew up, in the farm I grew up next to outside of Pittsburgh, grew continuous corn for the 22 years I lived there. It was crappy looking corn after 22 years. So I really didn't literally see soybeans until I went to Georgia for my studies, but apparently there's a bunch of soybean producing counties in Pennsylvania. But anyway, back to you guys. This is kind of the front edge of soybean cyst nematode spreading in the Midwest. And then I'm kind of a national keeper of the map, and the last time I updated the map, I decided to put them all together and make this animation so you can kind of follow the spread over the years. So it started out here in North Carolina in 1954, and within a few years it had jumped to the boot heel of Missouri. I'll just let it cycle through a couple times. And it jumped from the boot heel of Missouri to up here. And the story is that somebody bought a piece of farm equipment from down here and moved it up here. I've heard that story in Iowa, and they say the guy lived in Minnesota, and the folks in Minnesota say the guy was from Iowa. I don't know if any of that's true, but apparently or supposedly it moved up and made this big jump on farm equipment. Soil, we should say, on farm equipment. Okay, and then lastly, in the mid-90s, so this is getting to be 20 years ago, we did a truly random survey of 6 states, and Iowa, Illinois, Indiana, Ohio, Missouri, and Minnesota. And those percentages I put on the map are the percent of fields in each state that we found it. Then we did the survey again 10 years later in Iowa, and it came out to 72%. So it doesn't look like it's going to end up in 100% of the fields in Iowa. I was really shocked to see that percentage come in just about the same. And then somebody else in Illinois did, about 15 years after this, they did another survey, and they came up with 82% in Illinois. So it might be that the nematode spreads and then it reaches some maximum distribution. So I don't go around saying absolutely every field in Iowa is going to have cis nematode, but it's a good bet that 3 out of every 4 fields are going to have it.
Are those fields that had soybeans only on, or is that every field? Like, because there's a lot of corn.
Yeah, so these random surveys we did through the U.S. National Ag Statistics Service, and they have something called the Objective Yields Program, and that's how they predict crop yields. And so those were fields that had soybeans growing in them the year that they were sampled. Yes?
Any information on why certain fields don't, just by crop rotation?
His question was, is there any information on why certain fields don't seem to get it? And we don't know. Nobody that I'm aware of has ever. So let me just say that I'm guessing that there are certain fields that it just doesn't get established in. That hasn't been proven, and therefore we don't really know what the mechanism of that would be either. But just keep in the back of your mind, there are fields that have maybe more natural enemies, things that eat nematodes, and certainly people have identified them and isolated them and even tried to grow them up and then add them back into the field, and usually that fails. But it's hard to say.
What are the numbers on infestation on the central states? How many parts per million or how many?
So what about the numbers of these states?
Yeah, what is a heavy infestation?
What is a heavy infestation? Well, the record my lab has ever seen is 310,000 eggs per half a cup of soil. And that actually was a sample, for some reason, it came from Ohio. I would say anything above 10,000 eggs per 100 cc's or half a cup of soil is pretty healthy high in Iowa. But I've seen in 30, 40, 50, 60,000. I can't say I remember any above 60. Has anybody seen any higher than that up here yet?
A sample of Minnesota was at 200,000 in Clay County.
So there you go. Really, if you want to figure out how high it could go, let's go back to, especially if you're into math, start out with a really low number like 200, and then assume that each 200 eggs in the beginning of the season produce 200 offspring. So multiply 200 by 200 and do that 3 to 6 times. And it's incredible how the numbers build up. It's in the millions. Now, of course, in nature, not every egg that's produced survives to produce offspring and so forth. But the numerical possibilities of an individual making 200 offspring and having 3 to 6 generations per season, it's pretty mind-boggling how it's exponential increase. Other questions? We've broken the ice.
How did the cyst come into the country originally?
How did the cyst come into the country originally? So it was found like down right here, part of North Carolina, and it was near a port that received shipments of ornamental plants from Japan. And it had been known in Japan since the mid-1800s. And it showed up in North Carolina in 1954. So some people believe it was brought in on the dirt that was around these shipments of ornamental plants. Now the other hypothesis I've heard is that most people don't know that soybeans are not native to the United States. So Henry Ford was involved in establishing soybeans and getting them grown. Well, you know, all the nitrogen nodules on your soybean roots, that's caused by a bacterium that also wasn't native to Iowa. And so the story is that some brilliant scientist from the USDA brought in boatloads of soil to introduce that nitrogen-fixing bacteria, and they scattered it in the fields, and they would have introduced the bacterium, but they also could have introduced soybean cyst nematode. We should be able to track that one down, and I've never seen it proven or disproven. The more common theory is it was brought over on ornamental plants, soil with ornamental plants. Okay, some more survey results. Sam Markell from NDSU shared this information, and Brandon, I think it's the exact same information that you had shared with me. And so this is a grower survey done by NDSU, funded by the soybean checkoff dollars through the North Dakota Soybean Council. And so here's a map of all the sample points for 2013 and 14 combined. And it might be hard to see the color scheme, but the black circles are zeros, the dark squares are low counts, the yellow triangles are kind of medium, low medium, the blue circles are kind of high medium, and the yellow is bad. It's 10,000 plus. So there were the results, and spatially located for years combined. And then in this next slide, Sam took out the zeros, so these were only the positives. Again, these squares are 50 to 200, which is really low. And then he points out, this is absolutely true, low levels may or may not be true readings. It's really easy to get a false positive when you have an egg count of 50 to 200. And we should point out, an egg count of 50 means we've seen one egg under a microscope. It's not 50, because we do a dilution of 50. So we don't have time to go into the whole extraction process, but at the end of the process, you end up with a little beaker of liquid with supposedly the eggs, if they're there. And we can't count all that liquid, so we bring it up to 50 milliliters, we stir it up real well, and we count 1 milliliter. So if we see one egg under a microscope, we have to multiply it by 50 to account for the whole 50 mils that was in that beaker. And so these egg counts represent only seeing 1 to 4 eggs under a microscope. And they very well could be stray eggs from the good nematodes that we talked about earlier. All nematode eggs look the same, so there's no way we can tell them apart. So I think there were samples from, well, there was only one sample from whatever county this is in the northeast corner. And then there were a bunch of samples from down here in the southeast, so here's a close-up of those sample points and results. Again, the same color scheme. The black circles are zeros. We're going to take them out, and here are all the positive. But again, remember, a lot of these squares could be false positives. I do tell you that is a little bit troubling to see so many bright yellow squares. But that's not uncommon. In Iowa, we would have seen something like this in the late 80s and early 90s. It was first found in Iowa in 1978. So when a pest moves into a new area, it goes wild. And there aren't many natural enemies in the soil that attack it. That happens slowly. And eventually, you'll see fewer and fewer of these really high numbers. And in fact, some people say, well, we should just let nature take its course, and eventually all the natural enemies are going to catch up to the nematode. And I say, no. Meanwhile, a whole bunch of farmers go bankrupt. We're not going to do that. So that is not the right way to control soybean cyst nematode, is to let it run rampant until all of its enemies build up. But we do see high numbers now again in Iowa, but we saw really high numbers in the late 80s and early 90s, and then in the 2000s, the numbers kind of tailed off. And now they seem to be resurging again. But this is troubling, but not unexpected, I suppose, your high egg counts. Okay, probably the most important slide of the whole presentation. This picture is the most common symptom of soybean cyst nematode in the Midwest. And the lighting isn't perfect here, although it's pretty good, but I'll just tell you those soybeans are chest high, and they're perfectly green, and they're uniform in height. and when you dig the roots, this is what you find. You just can't assume you don't have cyst nematode because your beans look like this. And that's the hardest thing to get over mentally. I understand it. You have enough problems that are obvious that you want to deal with. You've got to start looking for a problem in beans that look perfectly good. But it's the truth. Beans that look this good have this going on underground. So there are two ways to scout for soybean cyst nematode, and neither one of them involve driving in an air-conditioned pickup truck at 65 miles an hour, okay? You've got to get out of the pickup truck and either dig roots and look for these white females or pull soil seed. And there are advantages and disadvantages to each. Neither one is terribly complicated to do. We don't have time to get into everything that you need to know about that, but the blue pen and the red pen you have in front of you have a unique feature. And that feature is, if you look at the pen, it's got a silver thing on the side, and it's got a banner that pulls out, and it will tell you the ins and outs of how to dig roots and look for females or how to pull soil sample. Any questions while everybody's checking that out? Yes. Okay, this is the first question that relates to a slide that we're going to get to. His question was, why do certain eggs hatch when they do, or why don't they hatch, and their survival and so forth. You asked the question much more articulately than I just repeated it. But I know the essence of your question, and the answer's coming up. Other questions? Okay, point number 2 on realities of growing soybeans with SCN in North Dakota. SCN can outlast any soybean farmer, even the tough ones in North Dakota. And what I mean relates to your question. Corn is a great way to manage soybean cyst nematode. And this graph shows soybean cyst nematode numbers after a year of soybeans and then 1 year of corn. And look at that drop. In Iowa, we see up to 50% of a drop in 1 year of corn. So man, if you could get that 2, 3, 4 years in a row, it would be good to go. Well, Mother Nature is smarter than that. 2nd year corn, the drop is less. And by 3rd year corn, it really flattens out. And it relates to your question, the answer to your question. Why can't we eliminate soybean cysts with continuous corn? It's because not all of the eggs hatch out in any given year. Remember I told you these eggs are all mixed up genetically? And we think they have 3 different types of behavior, hatching behavior. Some hatch during non-host years. I call those the really dumb eggs because they just hatch and then they're like, oh crap, that's corn that's growing, not soybeans, and they're gone. Then there's some eggs that hatch only when hosts are grown, like soybeans. And those eggs are only moderately smart because imagine if you planted a soybean crop and got all the eggs to hatch out, and then you could plow that soybean crop under and kill all those nematodes. So some of the eggs, the really smart ones, don't hatch for 8, 10, 12 years. And those are the really smart ones, they're dormant. And so it's a mix of these eggs that are inside each dead female or cyst, and therefore it's the really dumb eggs that are hatching out that 1st year. There might be some residual dumb eggs hatching out a 2nd year of corn, and maybe some coming out of dormancy, but after a couple years, all that's left are those dormant eggs in the field. So you can't get rid of soybean cyst nematode by growing corn or oats or alfalfa, and the shape of the curve would be the same. But I want you to focus on this. You can really knock back soybean cyst nematode with a year or 2 of a non-host crop. So did that kind of answer your question? Okay. Other questions?
So do they attack alfalfa in a similar way to soybean?
No, so soybean cyst nematode in Iowa, the other crops that it would encounter would be corn, oats, alfalfa, and it can't feed and reproduce on any of those. Now up here, you've got to be mindful of edible beans. And Berlin Nelson at NDSU has done a wonderful job of characterizing soybean cyst nematode on there's all kinds of different, you all would know better than me, the different types of edible beans that are grown up here. And soybean cyst nematode loves those edible beans. But it's not all legumes, it's just certain in the phaseolus.
So what about planting alfalfa in an area where you have bad cyst nematode problem? 4 or 5, 6 years or whatever?
Sure, I love you, man.
Yes.
That would be great.
Well, would it be a similar response to putting corn
Yep.
out for the first year?
Yeah, can everybody hear his line of questioning? Yeah. I'll say I expect it would be the same. I've only studied this continuous type of non-host crop with corn, but I've compared corn to oats to alfalfa in a single year, and we got exactly the same results. So I wouldn't have any reason to believe this shape of this curve would be any different with alfalfa or oats. Those are the only three I've worked with, corn, oats, and alfalfa. But yeah, that certainly would be one way. I mean, these nematodes, they're not vampires, they're not immortal, so they are going to eventually die out. It's just if you can outlast them. And Mother Nature's pretty patient with those dormant ones. So absolutely.
Can you get rid of with deeper tillage rather than the vertical shallow tillage? You can moldboard it in the ground with that?
You know, I was talking to Sherry before we got started, and she asked about overwinter and the cold killing them. And so when I moved here, when I got the job, before I even moved here, I thought, this is going to be the easiest thing to do for me as a professional, to work to control soybean cyst nematode. How can anything live over winter up here? And it's exactly the opposite. Up here, everything freezes, and so you're even more up here than I am in Iowa. Throughout a winter, everything is frozen. And so none of the natural enemies are attacking the nematode, whereas where I came from in Georgia, the nematodes are lying there in the soil over in the winter because there's no crop being grown, but all of its natural enemies are eating at it. So in Georgia, we see 50% overwinter death in a winter. In Iowa, we see 0% overwinter death, and I would expect the same up here. Now to your question, so when it came up here to Iowa, I said, well, we're not getting any overwinter death. What if we till, either deep till or shallow till, right before winter sets in? And we saw absolutely no effect whatsoever. Now tillage will spread it. So there's a benefit of no-till in that you're not dragging it yourself across the field. And with a research project funded by soybean checkoff dollars, we in the 90s showed that you can move soybean cyst nematode about 3 feet per year doing just conventional tillage. So it's not, you're not going to drag it from one end of the field to the other, but you are spreading it with tillage, and it doesn't seem to affect its overwintering.